Today I want to share my development workflow with AI. I want to share how I start working on a new feature, how I manage product requirement documents or PRDs, how I write code and test it, and how I move through the development lifecycle. The way I approach all that today is very, very different from the way I did all that in the past. There is a whole team working on each and every single feature, with me being the only human involved. You will see a very effective, yet very simple approach to development with AI. You will see a model, a few agents, one IDE, several MCPs, and a lot of memorized instructions, all of them combined into an effective workflow. You will see how I orchestrate all those with a relatively small number of instructions that expand into quite a few tasks executed autonomously. My motivation is quite selfish. I want to share with you how I do what I do in hopes that you will share with me your approach. I want us to learn from each other. All in all, I will share my AI-based workflow and I encourage you to share yours so that we can learn from each other. How does that sound? We'll take a quick break for me to introduce you to Blacksmith, the sponsor of this video. Here's the story. No matter which AI agent you use, you will eventually push code to GitHub, and that will trigger GitHub actions that will build binaries, run tests, make a release, and do whatever else workflows normally do. That's where Blacksmith comes in. It makes your GitHub actions much faster and cheaper at the same time. And all you have to do is change a single line in your workflows. A single line for faster and cheaper workflows that make them run on high-performance CPUs instead of GitHub's old servers. On top of that, they made significant software optimizations that allow you to get much faster Docker builds and faster collocated cache. Unlike some other solutions you might hear about here in this channel, this one is truly a no-brainer. Sign up, add that single line to your workflows, and enjoy faster GitHub Actions workflows at much lower price. Big thanks to Blacksmith for sponsoring this video, and now let's go back to the main subject. Let's say that we would like to work on this project, which happens to be a CLI written in Go that I use to manage videos in my YouTube channel. If you would travel back in time, adding a new feature to this project would typically start by someone deciding what the feature is, and then writing a detailed product requirements document that contains all the information one might need to understand what's it all about, which technical decisions should be made, the architecture, all the tasks that might need to be done, and whatever else we might need. We could spend anything from minutes to days on the PRD alone, before a single line of code is written. Once we are done, we would store that PRD in whichever issue management tool we might be using. That could be Jira, in which case I would have to quit my job and move somewhere else. Since my relationship with Jira is the same as my relationship with the guy that bullied me in school, we'll use GitHub issues instead. So let's do just that. Let's create a PRD and store it as a GitHub issue, but this time with Cursor agent. We'll start by instructing it to create a PRD. Currently, the project outputs on the screen information that the user should set language of a video uploaded to YouTube manually. And I want language selection to be always set to English and set automatically when a video is uploaded. Just in case that memory is not working, we'll instruct the agent to use Taskmaster to create that PRD. Now, to be clear, there's much more involved than that prompt. We'll see later how I instructed the AI to do everything it is and it will be doing. For now, the detailed PRD is stored as a GitHub issue and anyone can work on it. Quite a few actions were performed as a result of that prompt. Among other actions, the agent used Taskmaster to create the PRD. I will not go into details of how Taskmaster works here in this video, since I already did that in the video over there, so check it out afterwards. The gist is that Taskmaster is one of my favorite MCP servers that handles tasks related to PRDs. It creates them, it breaks them into tasks, and it orchestrates the work of coding agents so that all the tasks are eventually done. It's awesome. After the PRD was created, the agent called GitHub MCP to create an issue based on that PRD. That alone is a huge improvement. Gone are the days when we would spend more time wondering what a request to develop a feature or a bug fix is all about. The PRD created by Taskmaster was converted into a GitHub issue, and the comment was added indicating that we started working on it. As a result, that and all other issues in that repo now contain all the information one might need. Having detailed information in issues was always important. But now that we are using AI, it is essential. We'll see later why. Normally, at this point, I would review that PRD and, if needed, provide additional instructions to fine-tune outcomes. No AI is perfect, and trusting them blindly is not a good idea. At least not yet. However, for the purpose of brevity, I will skip that rule today. And you should not, and I repeat, do not take that as encouragement to do the same. Most of my time, however, is not spent on creating PRDs, but on implementing new features or fixing bugs. So let's switch to the next phase and see how I decide what to work on. When I start a new session, the first thing I do is discover what the pending PRDs or bugs are and decide which one to work on. That's easy. All I have to do is ask the AI, hey, get PRDs. Thanks to the memory graph that we'll explore later, the agent understood that means that it should retrieve all the issues from GitHub and filter them based on the PRD label. The final result is the list of all the PRDs we might work on. Those were all created by Taskmaster, but this time they're coming from GitHub issues. Now, most of the time I do not know the details of a PRD. Even if I wrote it, I'm too old to remember it. So my next step is usually to ask the AI to show the details of whichever PRD I might be interested to work on. That over there results in yet another trip to GitHub to retrieve all the details from the issue I referenced and output the details, all the details. Okay, now finally, after digesting the PRD, I prefer checking how hard will it be to implement it. Quite a few things over there need to happen for it to analyze the complexity. Among other steps, the AI has to figure out all the tasks required to complete the PRD and use that information to calculate how complex it might be to implement it. In this specific case, there are 20 tasks in total, and many of them split into subtasks. There's 88 of those. With the system I'm currently using, that would probably be a couple of days of work, maybe a week. Not today though. Today I expect it to take a few hours in total. It could probably be done in half an hour, but I prefer taking it easy and reviewing each step of the process that is about to start. Still, moving from a week of work to a few hours is quite an accomplishment. From here on, I could repeat the process and explore other PRDs, or I could work on that one. And that one we just explored seems fun to work on, so I'm ready to do some real work. It took the AI a few moments to organize everything. It gathered all the info it needs and generated whichever resources it needed to be generated. Once it finished the preparation, it suggested that I should work on the first task, recommended that there should be 5 subtasks, and asked me whether I want to expand those subtasks. Most of the time my answer is just do it, which results in creation of those recommended tasks through Taskmaster connected to Anthropic Sonnet model. This is when it truly starts. The agent sets the first task to in progress, then the first subtask also to the in progress status, and starts writing code and tests. Next few hours is spent on AI working on each of those 88 tasks and me correcting it and providing more information. Think of me in that process as a code reviewer and AI agent with everything else I set up as a developer. It is effectively doing the same job I was doing before, and probably disliking me just as much as I disliked people who were reviewing my code in the past. Probably. Now, I will not bore you going through all those few hours of work, so let's jump to the end of the process. One might think that after we're done with coding, we're done working, right? I'm sure you're not one of those. There are quite a few other tasks we might need to perform once the code is done, or to be more precise, when we think it might be done. We should create a branch, if we haven't created it already, push changes to it, create a pull request, ask someone to review those changes, implement suggested changes, approve the PR, and merge it to the main branch, delete both local and remote branches, execute CI/CD workflows that will do whatever workflows do, and potentially quite a few other tasks. In the past, all that could be time demanding and maybe even considered chore, a waste. Not today. Today, all I have to do is tell the AI that we are done. As a result of that single sentence, the AI agent, the model, a few MCPs, and most importantly, instructions I stored in agent's memory kick in and start the final process. During that process, the current status is checked, modified and new files are staged, new branch is created, staged commit is pushed to it, a PR with all the details is created, code reviews done by multiple other agents are performed, and I'm presented with findings. From there on, I can choose to implement suggested improvements and fix the issues that were detected. Once I'm done with that, the process continues. The PR is merged, the branches are deleted, temporary files are removed, and I'm done. Unless the workflows that are triggered notify me of another issue, something else. By done, I mean that it is built and tested and released, and the tag was created, the application is deployed, and whatever else my workflows might do. Now, I probably missed to mention all the tasks that were performed. That does not matter. What matters is that all that is done exactly the way I want it to be done. And all I had to do is tell the AI that I am done. AI did not do what it thinks it should do, but executed the tasks that exactly reflect my process and my way of working. It's awesome. I'm done. That PRD is fully finished, and the only question left unanswered is, how did all that happen? Everything I did today might sound complicated to set up. Everything we saw did not happen by using Cursor or any other AI agent out of the box. This is a custom solution, yet it is a solution that is very easy to set up. It's a recipe with the following ingredients. We need an LLM model, an IDE, an agent, a few MCP servers, and quite a few memorized instructions and processes. You're already probably using LLMs and IDEs, so I will not go deeper into those, except to say that right now I prefer using either Google Gemini or Anthropic Claude Sonnet models, and that my favorite IDE is Cursor, that already comes with an agent. You might have made different choices, and that's fine, since the rest of the setup works in more or less any combination. Next, there are MCP servers, so let's take a look at them. Unlike some other projects I'm working on, this one uses only 4 MCP servers, which, in my opinion, are essential. The most important one is memory, which contains all the instructions agent needs to understand my way of working. That's how, for example, it knows that it should execute a bunch of tasks when I said that we are done. Now, to be clear, you do not necessarily need that MCP since most agents are capable of managing their memory. I prefer that MCP since agents are changing very fast and I often switch from one to another. And while doing that, it is important for me to keep the same memorized instructions. If you opt for built-in memory, that might require conversion from one format to another. And then comes Context 7, which provides up-to-date documentation from thousands of projects. Further on, there is Taskmaster AI, which manages PRDs and orchestrates the agent to work on tasks that constitute a PRD. I extended Taskmaster's capabilities through additional instructions stored in memory, mainly focused on using GitHub issues instead of local files. Finally, the last MCP is GitHub, which enables interaction with, as you can guess, GitHub. Logical, right? That one might not be necessary since agents are perfectly capable of using GitHub CLI. Nevertheless, MCP tends to work better. So, there it is. I will not go into details about those MCPs since I already explored them in those videos over there somewhere above my head. If you feel like using the same MCPs, you can just copy and paste the JSON from the output. The main and probably the most important part of my setup are entries inside the Memory MCP. So let's take a quick look at those related to PRDs. Not to all of those, only those related to PRDs. There are currently 17 memory entities related to PRDs. There are instructions what to do with pull requests, code coverage, test-driven development, PRD handling, and so on and so forth. It would take too much time to go through all of those. AI should have created a separate JSON file with those so you can explore them on your own. Just do it later. Now, you're free to use them, but I advise against it. Use them as inspiration, but create your own that match the way you work. If you do that, do not overthink it. Do not try to capture everything at once. Instead, I suggest to keep updating it while you're working. That's at least what I do. The moment I notice that the agent is doing something I don't want it to do or doing it in a different way than how I like to work, I write a prompt that says, update your memory with this and that, whatever this and that is. Similarly, if you know that there are processes you execute often, instruct it to memorize them and associate them to a sentence like, hey, memorize that when I say that we are done, you should do this and that, whatever this and that is. The last component is the least interesting since everyone is almost certainly using it. There are workflows that are executed as a result of creating a pull request or merging it to the main branch. In my case, those workflows are defined as GitHub actions. Now, this is not a video about workflows, so I will not go into that workflow or any other, mostly because it's boring. The last part I should mention is the very beginning of each of the sessions I start. The first thing I execute is always the same. It's retrieval of the entries from the memory graph. I do that by executing custom cursor rule. That way, every time I start working, I know that the agent gets all the instructions I assembled and stored in the Memory MCP and follows them depending on what I instruct it to do. If you want to take a look at that rule, here's how it looks like. It is a simple one that instructs the agent to retrieve and process all information from the Memory MCP knowledge graph to guide our session. If you're not using Cursor, other agents tend to have something similar. For example, Claude Code has custom commands, so you should be able to do something similar no matter which agent you are using. And that's it from me. I shared one of my workflows. Today that was development of an application, but there are others. I have similar, yet somehow different workflows for managing infrastructure, another one for operations, and so on and so forth. Now it's your turn. How do you do whatever you're doing? Please share in the comments. Thank you for watching. See you in the next one. Cheers.